Hello, this is Mrs. Scarpel, and I'm going to take you through factoring some more trinomial expressions, but this time the expressions are going to start with a value other than 1x squared. As you can see in these two examples, one is starting with 3 and the other is starting with 2. Now I'm going to start with thinking about when we were completing the square, we took this leading coefficient to mean the number of blocks we needed. So I'm going to check to see if it would be possible to spread all of these values evenly over 3 blocks. So that would mean, does the 21 divide evenly by 3? It's 7. Does the 36 divide evenly by 3? That's 3. So if I write this with what we call the common factor factored out, which is 3, each block will have x squared. 21 divided by 3 is 7x for each block, and 36 divided by 3 is 12 for each block. So when I go to factor, I'm going to have my 3 blocks, and I'm going to attach them. And they're each going to have an x squared. They're each going to have 12 units. Because as we learned from prior factoring, if we know A and we know C, we can use that to help us find B. So I know that to get the area of the x squared, that's taking x times x. Now for 12, I need to look at what are my factors of 12 that I can combine to get 7. So factors of 12 are 1 and 12, 2 and 6, 3 and 4. And the pair that will combine to give me 7x would be the 3 and the 4. So we have 4x and 3x in each of these blocks. And if they're both positive, then we get that positive 7x. So that means the 4 needs to be positive on each of them, and the 3 would be positive. And if I double check that, and I see that I wrote a 3 where I should have a 4, positive 3 times positive 4 is positive 12. So the factored form of this is we've got 3 blocks with the dimensions of x plus 4 times x plus 3. And you can even see that we ended up with 3 x plus 4 dimensions within our model. Now in class I had a student ask, would it be okay to just draw one block, and if there's multiple blocks, to put that number in front, so to put our block in parentheses? So before I go much further here, let's first check to make sure that it would be multiple blocks. So my expression would indicate that potentially there are 2 blocks. Can we divide 2x evenly over each of those 2? Certainly, we can create x squared here, x squared in each one, and a 1x in each one. And then with the minus 4, can we split that evenly? Certainly, with a minus 2 in each one. So we have x squared, and I'm going to show that we actually are going to have 2 of these. So I'm going to put my block in parentheses with a 2 in front. So it looks similar to this expression up here where I factored out the common factor of 2. To get our basic square, that's x times x. We know there are minus 2 units. Now the nice thing about this problem is that our only factors for 2 are 1 and 2. So we may need to take a look to see if we need to make either of them negative, which I believe one of them should be since we have negative 2. So we go back and we look at the b value. This is a 1x. 2x minus x will equal 1x. So this becomes x minus 1, and the other side is x plus 2. And you can kind of see a factored form already from the way that's written. We have 2 blocks that have dimensions of x plus 2 times x minus 1. Now, what if we have situations where it wouldn't split evenly over 2 blocks? So if I look at 2x squared minus 13x plus 15, the 2 would indicate I could potentially have 2 blocks or 2 area models. When I look at the 13, I can't split the 13 evenly. I can't split it as an integer. It would be 6.5. Now that's okay if we're completing the square, but with factoring we're thinking in terms of rectangles. So since it doesn't pass the test of being able to be spread evenly over multiple blocks, we're going to have one block that we work with. And the x squared term, the first term, is still going in that upper left corner for 2x squared. The units are still going in the lower right corner for plus 15. So, to get 2x squared, well, I'm still going to have x times x. But to get the 2, I'm going to have to multiply an x by 2x for that to happen. Then we need to look at the factors of 15. So that's 1 and 15, 3 and 5. And we need to somehow get negative 13x. So I like to start with factors that are closer together, just because that tends to be the case. And if it doesn't work for us, then we'll go and try the 1 and 15. Because the thing we need to keep in mind is we need them to combine to equal negative 13. However, we also need to keep in mind that we don't just have x by x. So this 2 is going to affect what goes in this space below the 2x squared. So I'm going to try this with the 5 on the same side as the 2 and the 3 on the same side as the x. 5 times x is 5x. 3 times 2 is 6x. Well, to get 15, even adding these two numbers, the closest I get is 11. Now I don't want to give up on the 3 and 5. I'm just going to change which side I write them. So if we put the 3 on the same side as the 2x and the 5 on the same side as the x, I'm now taking 5 times 2. That's going to be 10x. 3 times x is 3x. Now those will get me negative 13 if they're both negative. So I need to check to make sure that if they're both negative, it will still work for my units. Negative times negative is positive, so far we're looking good, and 3 times 5 is 15. So the factored form for this expression is x minus 5 times 2x minus 3. And let's try one more of these. So I'm going to start with my block, and since I see the b value is 1, the only way I could spread 1 evenly is if I'm dividing by 1. So I know that this one is going to be in one block with a 3x squared in it and a minus 10 in it. Now the only way we can multiply and get 3x squared is if we multiply 3x with x. Then we're going to look at factors of 10. We have 1 and 10, 2 and 5, and just like before, I'm going to play with the 2 and 5 before I try 1 and 10. Just because, like I said before, numbers closer together tend to be the factors we're looking for most often. And I'm thinking about this, and I'm thinking if I take 2 times 3, that would give me 6x. And if I take 5 times x, that's 5x. And if 5 is negative, 6 is positive, so that means the 2 is positive, I will get the 1x that I have for my second term. Now I need to check to make sure I'm going to get the units including the sign. Positive 2 times negative 5, positive times negative is negative 10. So this factors as 3x minus 5 times x plus 2. Now, you might be thinking, isn't there a simpler way to do this than just by trial and error? There is a pattern. If we have it in the form ax squared plus bx plus c, we can find the value of a times c and find the factors of that number that add to b. And we can put those values in, and then we can work on finding the constants that we need on our dimensions of our rectangle. So if I just go back and I look, 2 times 15 is 30. The 3 and the 10 are factors of 30, and they did combine to give me the 13. Again, we have 3 times 10 here is 30. 6 times 5 will give me the 30, but they also will give me the positive 1x that I need. So I do have a couple that I'm going to do with you using that method. So we have 2x squared plus 9x minus 5. The first thing I'm going to do is take 2 times negative 5 and see that I have negative 10. What I'm going to check is what times another factor will equal negative 10, but when adding the same two factors of negative 10, I will get 9, because that's my b value. Well, for factors of 10, we have 1 and 10, and we have 2 and 5. And I'm trying to think how that's going to work to give me the 9. I think I'm finding one that isn't going to work based on the problems, the numbers I chose. So let's ignore this one for now and try it with B. I apologize for that error in that problem. We'll just go ahead and do problem B. So if I do problem B, I have 10 times 3 is 30. So what two numbers will multiply to give me 30 that will combine to give me 17? So if I think of my factors of 30, we have 2 times 15, 3 times 10, 5 times 6, and the one that I almost forgot that many people tend to forget is the 1 in 30. And I wrote up here that I wanted them to add to 30. It's not that I want them to add to 30, I want them to add to 17. So the pair that will combine somehow and get me 17 is this 2 and 15. So we have 2 and 15, add to give me 17. 2 times 15 gives me 30. So now, when I fill in my block, I can fill in the 10x squared. I can write 2x and 15x in here, and it doesn't matter where I place them. And I can place the units for 17 in, or for 3, excuse me, for 3 in here. Now, something that's going to help us out is the only factors of 3 are 1 and 3. So when I look at where I want to place them, I know I don't want 3 to go with this column, because the only way I could get 2 when I multiply by 3 is if I multiply with a decimal. So I'm going to put the 1 here, because 1 is a factor of both 2 and 3. And I'm going to put the 3 on the side here because it is a factor of both 15 and 3. So now I'm going to look at this, and what would I take times 1 to get 2x? That's going to help me get one of my x values. So to get 2x, when I multiply times 1, is going to be 2x. And what do I have to take times 2x to get 10x squared? That's going to be 5x. So instead of starting with what the units are for this square, I'm going to use 2x and 5x. And when I check this, if the 1 and the 3 are both positive, 1 times 3 is 3. That means the 2x and the 15x are both positive. 2 plus 15 does equal the 17 that we need. So this factors as 2x plus 3, 5x plus 1. And now I'm going to go back to that one that I didn't think would work. I forgot that we need a negative 10. So that's going to imply that one of the factors is negative. And when I think of 10 and I think of 9, the factors of 10 would be 1 and 10 or 2 and 5, like I had mentioned before. Well, one of them has to be negative. So if I try 1 and 10, in order to get 9, it would have to be a negative 1. So negative 1 times positive 10 is that negative 10. So I'm going to go back here and I'm going to draw this square, or rectangle technically. We know we have 2x squared. We know from what we found with the factors of the negative 10, and we need them to add to give us 9, that we're going to have a negative x and a positive 10. And we know that we have negative 5 units. So I could start with the units again. I know that my only option is 1 and 5. One of them is going to have to be negative. And what would I take times 1 to get a negative x? Well, it would be x, but the 1 has to be the negative value. Our x values will not be the negative values. So now I have that negative 1, positive 5 will multiply to give me the negative 5. What do I take times 5 to get 10x? Well, that's going to be 2x. And if we check, the only way we can multiply get 2x squared is x and 2x. So this factors as x plus 5 times 2x minus 1. Now I don't care which method you use for factoring. If you like multiplying a times c, and you can remember you're looking for factors of that result that add to give you b, go right ahead and use this method I used with these two. If you'd rather use the methods that I did on the second two examples in this video, go ahead and use that. Because like I said, having the model does help you verify your work, that the factoring will work. And this concludes my videos for factoring trinomials.